Hello, I'm Stacy Ross, and this is my presentation for Lab 1, Charge Tapes. The purpose of this lab is to observe the amount of excess charge on an ordinary object with respect to Coulomb's law and the concept of superposition. Coulomb's law states that electric force is equal to the constant K multiplied by charge 1 and 2 and divided by the magnitude of R squared. In this experiment, I prepared pieces of charged tape by placing one piece of tape on a flat surface, then another piece on top of it, which was referred to as the upper tape or U-tape. I carefully removed the U-tape from the bottom piece and observed its interactions with neutrally charged objects. Finally, I observed how two pieces of U-tape interacted with each other. From the experiment, I was able to observe that the U-tape was attracted to both my hand and the table, but it was repelled by the other pieces of U-tape. From this, we can conclude that the U-tape has the same charge. To determine what charge the tape had, I held the U-tape to a pin which I knew to have a negative charge. If the U-tape had a positive charge, it should be attracted to the pin. If the U-tape were neutral, it would be attracted to the pin. However, the U-tape was repelled by the pin, so we can conclude that the U-tape is negatively charged, meaning there are excess electrons. The following calculations were performed under the assumption that charge A is equal to charge B. We can make this assumption because the tape was charged using the same method in the same environment. We are also assuming that the tape can be treated as a point charge, we can ignore air resistance, and that the charge is evenly distributed. We can find the mass of the tape given the dimensions of the tape and the average mass of tape per meter. Using the gravity constant and mass of the tape, we can find the magnitude of the force of gravity on the floating tape. Given that there is a zero net force in the y direction, we can assume that the magnitude of the electric force in the tape is equal in magnitude to the force of gravity. Using the previous information and Coulomb's law, we can solve for the charge of a single piece of tape. The number of excess electrons can be found by dividing the excess charge by the charge of an electron. The ratio of atoms to excess electrons can be found using the dimensions of the tape and size of an atom to find the total number of atoms, and dividing the excess electrons by the total atoms. Using the previous measurements and calculations, I created a computational model in GlowScript. The code is based off of the source code from Lab 0. I started by inserting the constants, then the equations, and finally visualizations and printed outputs. The code produces the following model with printed statements regarding the calculations I previously discussed. What if? What if electrons had positive charge and protons had negative charge? If the electrons had a positive charge and protons had a negative charge, the attraction and repulsion we observed would be reversed. Why is it important to handle the charges taped as little as possible? What happens when the charged tape comes in contact with your hands or other objects? It's important to handle the tape as little as possible because touching it could cause the electrons to be grounded, losing the charge necessary for this experiment. That's all. Thanks for watching.